Welcome back to Munro Live. And as you see behind me, the Cybertruck is being broken down basically to its bare bones, and the individual components are coming apart so we can really look at what was done to accomplish this vehicle. So today we are going to look through the seats, front row seats, rear seats. What type of differences do we actually see? Because as mentioned in previous videos, for the most part, the Tesla seats across all of their programs have been the same structure carried over, same overall design and look. So I want to just point out the individual differences that make this unique and whether, in my opinion, it's a good direction or not.
Thanks to the Three-Dimensional Services Group for sponsoring this video. Whether you're looking to source metal stamping, precision CNC machining, laser cutting, welded assembly, or plastic injection molding, the Three-Dimensional Services Group should be the source to transform your EV, aerospace, appliance, or technology designs into reality, while also providing a bridge to start of production.
Hey boys and girls, I'm here with Dan, and we're at Three-Dimensional Services Group. And Dan, this is pretty impressive. Why don't you give us a little background on what you guys do here?
Okay, well, the Three-Dimensional Services Group was founded by Douglas Peterson 31 years ago. We've grown into the world's largest, most capable, and most agile prototype and low-volume manufacturer. In essence, we're a job shop on steroids. We work with the world's most innovative companies to validate their designs, and then we're able to take our low-volume manufacturing processes and scale them across a massive amount of equipment to allow us to support volumes that a traditional prototype shop would never be able to support. We're always working with our clients to accelerate their product development timelines and enable them to be as successful as possible by bringing their products to market as quickly as possible.
So first thing, we have to mention that of course this is a truck. So being a truck, the front seat sits higher up in vehicle. So a traditional Tesla seat would have seat tracks that would be mounting to the floor. This does not mount directly to the floor. It has to be raised. Now, these brackets, unfortunately the way it sits in vehicle, these are upside down, but because of the locator pins, I cannot put them on the table this way, so I have them upside down. They have these two large castings. There's actually four, since there's driver side and passenger side. These are being used to raise the entire seat structure up. That way they can use the same seat structure that they've used in previous vehicles, but this is the way they're lifting it. All right. We in generally like the idea of a casting being able to simplify processing steps. This is one component. Here's the problem. Here are the Tesla tracks. Normally, if you're doing a truck, you would take a track and you would weld on some sort of a bracket to lift it up off the vehicle. Now, when you do this, lots of times people don't like seeing all of that metal, so they'll put some sort of a black plastic cover over this, or they'll just paint it. These are these massive castings which weigh an awful lot. This one here is 2 kilograms. This is 2.8 kilograms. Now this is also from a Tesla, an early Tesla on the Model Y. This is lifting that up, but this is only 1.4 kilograms. But this is made up of stampings. There are 6 stampings here that are being used to lift up this vehicle. If we're talking about a casting, we normally say you can get all of these components into one, and that is true. If we're talking about a large component in the vehicle where we can take 50 stamping components and combine them into one, simplify that processing step, that is very, very important. That is big. But if I'm talking about 6, the cost of that casting tool, the increase in weight and mass, the fact that this casting material costs more on a base material cost than the steel, you get to a point where you have either diminishing returns or you're going backwards, where you're using that type of philosophy, but you've tapered it down to a product that is so simple, it's overkill, and you'd actually be spending more money. Now, if I try to give you an example of, well, where else would you see this? This isn't common in most trucks. Most trucks you would have some sort of formation that's going to come up out of the floor to take up some of the gap, and then the tracks would fit right to that. Or we would have a riser welded to the seat tracks. But of course Tesla, that has that nice flat floor. Well, because of that flat floor, we have this base. So where do you see this? Think about delivery vans. Lots of times delivery vans, delivery trucks, you have some sort of basically a box base that is lifting up that seat. Now that box base can be quite ugly. There is a lot of style that they've been able to integrate into the casting. So now you have this question. If I'm talking to a studio and they want a general look, how much money do I want to pay, do I want to put into the vehicle to get that look? There is no plastic cover, okay, but a plastic cover is so cheap. I don't know if they sacrifice those costs just for the look or if they're getting some other benefit. Now, here's a problem. Though we have now torn down these components to their individual base parts, I have not done the calculations yet. I've not done the mass calculations, the cost for the molding, the cost for comparing to a cost of stamping. Unfortunately, I don't have all those base costs broken out to really understand if they're getting a benefit or not. But let's move on. Here we have a traditional Tesla seat. Now, I had one big criticism with this seat, and it has to do with the headrest. Tesla has fixed headrests, meaning you cannot adjust this headrest for your comfort. But it is still a separate component. Being a separate component, there's an increased cost to the cover, there's an increased cost to having the two different types of foam, and there's an increased cost to the structure that's supporting it. So let's look at that structure a little bit. So here's the seat structure from the Model Y. We have a normal seat back frame. We have a plastic guide. Now with that, here's the headrest with the foam removed. I have a chromed tube that is now going into that guide. Separate foam, separate sewn cover. That chrome tube has one notch that is a lock position. Once it's in place, it's locked in place, it does not move. All right, we know that they're using this tube to lock the back panel for this model of seat. But let's look at this. This is from a Ford. Now the whole moving portion up here is unique, but look at those tubes. I have 3 positions. They also have plastic guides. I just press the side of the guide and I can move up, move up, move up. I get the adjustment. Tesla has all of the exact same components needed to provide you with an adjustable headrest. They're already paying for them, they're already in the seat, but they're not giving you the feature. So my criticism was, if this is a fixed headrest, it should truly be a fixed headrest. So here's a Cybertruck seat. This covering is all one piece. There is no removable headrest here. Great, I like that. Trying to get some sort of a style that is appealing in that shape. All right, there's some things that you can do around there, but in general, this should be a lot less expensive. All right, cover, all one piece. Very, very simple design. I like that. There is a small amount of savings there. The foam, one piece of foam that is poured. Simplifies installation, less quantity of tooling required. I like that. The structure. This is the exact same structure that's used on Model Y, Model S. Here are your tubes with the one lock position. Now this is plated, it just does not happen to be chrome. There are plastic guides, I don't have them with me here, but this component is locked in there. This inner structure, which happens to be very, very thick and heavy, then fits and locks to this component. Then our foam is provided and our cover is put on. All right. They're building up all of this assembly and all of those components in order to provide this shape. I will speak to the good and the bad. What's the good? They're using a common frame. This frame is already built, already tooled up. They already have it in their inventory. They don't have to purchase anything new there. But all of the other pieces that they now have to put in here in order to get this shape eats up a lot of cost and a lot of inefficiency. What I would like to have seen is this stamping alone, not the side rails or any of that. Keep all that. Change this stamping to allow it to fill up and have the foam fit right into that. That, I think, would have been simpler, more cost effective, eliminating some of the assembly with all of these extraneous components, injection molding tools, the bending, the plating process. But why didn't they do that? Well, Tesla's getting older. Tesla's becoming more of a normal car company. So when you're calculating the cost of the tooling, these things are already on the shelf. They already have this part. You go to the designers, we have a new vehicle. Studio says this is what I want it to look like. I then shoehorn this shape into something that I currently have existing. And then I have to make all of these band-aids to make it fit. That is a criticism that I would have. I don't know if it's completely fair. However, if Tesla is going to continue having a fixed headrest going forward, which I assume they will since I don't believe they've ever had an adjustable headrest, I think going into something tied more into the structural design for the long term would be the better approach. Looking at the cushion structure from the Tesla Cybertruck front seat to the front seat in the Model Y, all of this appears to be the same to me. So, okay, sharing components, that's very, very nice. But let's kind of look in the body. So we've talked about the front seats. Now we're going to talk about the rear. Looking at the back wall of the body, you see that is basically solid. There is no type of pass-through. I would expect these rear seats, especially the seat back, to be able to just fit along that body. But let's look at the components that we have. Here's a part of a rear seat back. All right, I have this side bolster that pops off on both sides. What is that bolster? That bolster is a piece of injection molded plastic with a formed foam bun that is poured in place on top of it and a cut and sewn cover on top of that. All right, so we have components like that that pop off. I have this center section with a sewn cover with a piece of foam, an additional piece of expanded polypropylene foam. Now I have an injection molded frame that is sitting up against the back wall. This structure is screwed, bolted in place onto the back wall. There is two of these, one for each side. These are non-moving components. All they're providing is support for the foam for the seat cover. Plastic can be lighter depending on how much you need compared to metal. However, not always. Sometimes a very, very simple metal design is actually advantageous. So let's look at this right here. This is a seat back frame from a Ford truck. This back frame actually does move. It has a hinge point, flips down, flips up, locks into place. Formed tubes is a lot simpler than regular stampings. So I have formed tubes, a few stampings, and some welding. I've calculated the cost of these, and I've calculated the cost of injection molded panels before. And for very simple structures like this, pound for pound, the metal is actually less expensive than the plastic structure. Now, though I have not calculated this particular vehicle, I've calculated things like this in the past. And normally for pound, or even size per size, often it turns out that a simple metal stamping with welding is less expensive than the large injection molding. Now, where am I going to get the savings? If I keep this shape across multiple vehicles, this large injection molding tool ends up having some savings there because it's the same part over and over. Less worry about trying to weld everything in the correct position, tolerancing, whatnot. But that's only if we assume that this shape will carry over to any other vehicle besides the Cybertruck. When we look inside of the complete vehicle, we can see when we pop off these two side rails, this is giving us access to the bolts that are securing the seat in place and also giving us access to the seat belts. Now, I don't know how many of you in the audience have actually torn apart or removed a seat from a vehicle, but this type of setup is not common at all, and normally access to all these features are provided in some other way, some more of a simplified way. Having to have this many components to completely close out the rear seat back, specifically a non-moving fixed rear seat back, seems like it's, in general, an overall waste. It's an excess that you may or may not actually need. So now let's look at the cushion structure. So the cushion structure is the only component that actually moves. This is the hinge component that's bolted back to the vehicle wall. This then supports the two sides of the seat. Here's the metal seat structure. This is all steel. These are all a lot of stampings. This is then painted. Now, when I have looked at these seats before, knowing that the back is fixed, all of this is just to support a seat that folds up and down. Ford and Chevy seats are much simpler, a lot less costly than this type of a system. I almost would assume that the engineer was given a target and said, we need you to develop something that does this. This is how they impressed their bosses. When you look at something that's very, very complicated, at first, this seems impressive. You marked off all the checks. It's very, very strong. It's going to support what we need. Has this feature, this feature, this feature. However, when you really look at it, the simplest design is the best design. And the best design, a good design, will often seem like common sense. You won't get credit for a good design. But something that is overbuilt and almost looks like a Rube Goldberg machine at first seems impressive. You're like, oh yeah, you did something great. But as we know, a Rube Goldberg machine is almost a useless machine to do a simple task. This could have been a lot more efficient. Let's look at this alone. This is basically a large piece of plate steel that was laser or water jet cut. There are 3 of them across here. This is about 1 centimeter thick. This is twice the thickness as you would expect to see on the frame rail of a full frame truck. This is twice the thickness of what we saw on the Rivian rear seat, which I was criticizing in that vehicle for somewhat being overbuilt. Now, this is my opinion. I have not seen the finite element analysis for this vehicle to know what they had to do to meet their requirements. But I would really question why this needs to be that thick. I don't believe that it was completely necessary. But that is my opinion on that. I think that this could be a lot more efficient. I think that they were trying to meet a goal, a system that would work, but they did not get the chance to come up with a system that was efficient. So lots of times you will somewhat overbuild something in a seat like this and make the claim, well, we need it for crash. If we are really supporting from this component, we do not want this deflecting at all in a crash situation. Now, the seat's really only going to deflect if the seat is weighted by an occupant. Basically, what you're doing is anti-submarining. You don't want the seat to deflect and the person to slide out from underneath the seatbelt. So you could give them the excuse of that's why this had to be so thick, to prevent anti-submarining. But look here. I have a touchdown surface. If I have a touchdown surface that is taking the load of my seat in line with that centimeter thick steel, this does not need to be anything more than a simple hinge. This is where you are loading your weight. I just think that this is excessive, in my opinion, again, without actually seeing the FEA results. The Cybertruck is really a vehicle that is designed to impress. If it is designed to show something that can be different, I have no problem with something that can be different. It is completely unique. Now, style, do you like that style? I don't, but there have been styles that I've disliked in the past that have grown on me and I've changed my mind over time. But beyond the look, does the supporting structure match what we're trying to do? Are we really reinventing? Are we simplifying? And looking at conditions like this, I would say that that mark was missed on the Cybertruck for these components. Now, there are other components within the vehicle that are unique, and we can speak about those in some other videos. So if you're not subscribed to Munro Live, please do, and we'll see you in future videos.